Hello YouTube, welcome back. This is a video about Lua script, and here are a few scenes. I have created 4 scenes, and the script for these 4 scenes are below these videos. These are the video files. Let us have a small preview of that. This is the first scene, and I have a script for this below this video file. This is the script of the scene, and let us continue to the next scene. And this is a robot, and it's holding a block through suction pad, and I also have the script for this is that script. And third video, uh, grasping of a falling cube, and fourth video is about the welding. Okay, now let us learn a little bit about the Lua script and the how to make the robot function based on the script. I'm opening the first scene. Right. These are the graphs that I have created, and this is a cube. This is more like an obstacle. And in the previous video, you might have learned about the obstacles and inverse kinematics, path planning, and all. And all those concepts are useful in this video. In this video, the forward path, that is from here till here, the robot follows my predefined path, and while returning back, it calculates its own path and then returns back. That if it calculates its own path, then it is called the path planning, automated path planning, and Vrep does that. And let us open the script for that. Yes, this is the main script, and the script, the total is the script. It has a 35 lines of code, and the script, this is the icon to open the script. Okay, let us learn. So initially, when you add a script, this gets added automatically. Thread function is equal to function. This is like a function, and while is also added automatically. You need not type it to the script. So while get simulation state is equal to simulation advancing about to stop. And if you want to have a more clear explanation of these 2 lines of code, then you can refer to the user manual. There are regular APIs, and yeah, you can refer to that Lua, or you can even refer to the Lua textbook for understanding how it works and what are the parameters needed for that. Okay, the first thing that you need to do is the initialization section. In this section, the section ends here, and the selected region is the initialization, and more or less you will see the same terms here. What are the things that were present here? All those things, most of the things will be present here. Like, see, this is the path. Yeah, this is that path, and it is case sensitive, capital P, and path 1 is also there. Yeah, here is that path 1. Let me highlight that. Yes, this is that path 1. The highlighted region is the path 1. Let me show that again. Yes, it is it. And the path is this. Of course, both are the same, but path 1 is moving from here till here. The 1, 2, 3, 4, 5. Whereas the path is reverse. 1, 2, 3, 4, and 5. And then comes the target. This target is the target dummy here. Yes, here it is. The highlighted one is the target. And then comes the prismatic joint. You probably know where it is. Even then, let me show you. Yes, here it is, prismatic joint. I have I'm sorry, I have not made it visible. Yeah, now it is visible. First layer is enabled here, and this is that prismatic joint. It helps the robot to grasp the cube. This joint activates when the cube comes near to the robot, and then it helps the robot grasp this cube through these two blocks. And these four are the parameters like manipulator velocity and gripper open position, gripper close position, and gripper action time. And you see that the manipulator velocity, the units for all these things are will be in mks, meters, kilograms, and seconds. So zero point 0.8 means 0.8 meters per second. And gripper open position, this is also in meters, it is minus 0.1 meters. Gripper, you see this is the gripper, the one that holds the prismatic joint. This part is the gripper part. So open position means the distance between these two is 0.1 meters, which is 100 centimeters. Sorry, 10 centimeters. 0.1 meters is 10 centimeters, and gripper close position is 0.045 centimeters. It means it closes at 4.5 centimeters. So the play between that is around and gripper action time is 1 second, and default position is, this is the API that I have used, simget object position target comma -1. It means that we have a target over here, target dummy over here, and we are referring to it as the -1. It is called as the object reference point. And what I'm trying to do here is I'm trying to get the object position through the API, and I'm storing it into a variable called default position. So default position stores the x, y, and z coordinate of the target, and default orientation also does the similar function, but this time it saves the orientation, which means the inclination with the x, y, and z axis. And here we call it as alpha, beta, and gamma. So it saves the default position and default orientation, and it makes use of these two in in the main script. This is a main script. Oh, yeah, here it is. Yes, I have defined it twice. Like I'm sorry for that. I have also defined the same command over here. Position is equal to simget object position, and orientation I have not used it anywhere. It's okay. It depends on your application. Right over here, you may or may not use the orientation command. So let me delete these two lines. And here let us start the script. Sim clear integer signal box detected. It means that here there is a proximity sensor, right here it is, and when the cube falls and when it starts moving through the proximity sensor, the proximity sensor detects that the object has passed through this ray, and it will send a signal send the signal to the script that the object is moving. And I'm making use of that signal. First, I'm clearing the signal, integer signal. I'm clearing everything. It means that initially there is nothing, and then what I'm trying to do is I'm waiting for the signal. I'm waiting for the proximity sensor to tell the script that it has detected a block. If it has detected a block, then further code happens. Further code, which is position. The target position is detected, this position is detected, and then position of 3 bracket, in the brackets if you write 3, then it means that it is the z position. And if I put position of 2, it becomes the y position, and if it write position of 1, it becomes the x position. What I am trying to say is, this is the x coordinate, this is the y coordinate, and this is the z coordinate. Initially what I've done is I am storing the target position x y z position into a variable called position, and then I am trying to extract only the z position, because here in the robot, here in the scene, you will notice that it is in xy plane. The cube and this manipulator are lying in the same plane, xy plane. Only thing that you should worry about is the z is the height. When the cube falls, we are trying to match the robot to the height of the moving cube, but not x and y, because it's lying in the same plane. It's it's not needed to match the x and y variables. So position of 3, it means the target position should, the new target position should be 0.13 meters above. Oh, sorry, should be 0.13 meters below this particular position. It means that from here till here the height is 0.13. You will get to know about this practically, or maybe through measurement, like maybe trial and error. You could try any method you like. And after that, I am making the robot move to the position, sim move to position, and target moves to any position. So the position now is 0.13 meters less than the previous one, which is here. Our new position is here. Now the robot, this particular command makes the robot move from this position to this position, comma nil. Nil means I'm telling the robot not to follow any orientation. Orientation could be anything. The default orientation is like this only. And then manipulator velocity. My manipulator velocity is 0.8 meters per second, and I'm trying to reduce the manipulator velocity to 25%. You could do the math over here. Math into 0.25. And then sim set joint target position. Now after the robot reaches to this point, let me preview. Yes, now it is probably in this command. It's following this command. Or what this command says is, the prismatic joint should activate the gripper close function. Sim set joint target position, it means the prismatic joint position uh, is defined over here. It means it has to close now. That's what I'm trying to say. So when the cube comes close to it, the joint should close, and the closing parameter is minus 0.045. These are the coordinates. These are in local coordinate system. So it closes here. As soon as it closes, it should follow the path, sim follow path, and it should follow the PATH, this particular thing, path, with a velocity of 3 meters per second and acceleration of 0 meters per second, and it is following with a velocity of 0.8 meters per second. It means the manipulator velocity is 0.8 meters per second. From here till here, it is 0.8 meters per second. And then let me okay, let me continue with this scene. Yes, fine. Now the robot is in this 16th line of code. Sim set target position prismatic gripper open. Gripper open is minus 0.1 meters. What it does is, after reaching the path, after completing the entire path, it simply opens the gripper so that the cube falls. You see how it works. Yes, now this particular line of code has been executed. As you can see, the gripper opens and the cube has been made to fall down, and then sim wait gripper action time into 2. What it does is, it waits the simulation, it holds the simulation for about 2 seconds, because gripper action time is 1 second. I have multiplied it with 2, so it waits for 2 seconds. Yes, and immediately after that it follows the sim follow path, uh, path 1. This time it is in different path. Previously it has followed PATH path, and this time I made it follow PATH1 with velocity 3 and acceleration 0, with the manipulator velocity 0.8 meters per second. And you see, this particular line of code is not executed because it is in green colored, and it is in green color because of these two dashes that I have kept. Let me delete that and it functions. Let me put that and it won't function. It is more like a comment line. For your understanding purpose, you could add comment lines like this. uh, this is a comment line. Yeah. Huh. And with this particular explanation, I have completed the pick and place robot script explanation. And one more thing I want to discuss is all your script details. If you, in case of any errors or something, you could see it or right over here. So this is the console window, and simulation launched, scene opened, scene stopped. As far as uh, now, there are no errors at all. In case of any error, it will report it here. There is some error in this particular line of code, so that you can edit that. You can make the modifications and then continue. Okay. Let us open the another scene, and that is this peg-in hole. There are two blocks and there's a cube inside. There is this robot, it holds the cube through suction pad, and this is quite a bit laborious task, and this is a little bit tougher. Even it's okay. I'll teach you in a simple manner so that you can understand it very clearly. Okay. First of all, I want to tell you the components of this robot. So as usual, I have a base, I have a different links for that, and I also have a gripper mechanism, and yeah, there's a prismatic joint here. In this case, the prismatic joint, it just closes, it's not activated. I have fixed the prismatic joint, and this is the suction pad link. I have taken the suction pad through the model browser. From the model browser, components, actuators, sorry, in the grippers, yeah, in the grippers, yes, there is a suction pad here. I've simply dragged and dropped it into the scene, and the suction pad is like this. You can position it, you can orient it, and this is the final suction pad. And this suction pad has to be linked with your robot, this is our scene, no, robot one, and all the tree hierarchy is maintained. And similarly, section pad hierarchy is also kept with the components, and these are all default. When you drag and drop it, all these appears, all this comes automatically. You need not add as particularly, especially these dummies, you need not add it specially, it comes automatically. So, and there's a script for the suction pad, and this script is uh, preloaded into the script of the suction pad. What I have done is I have made a small modifications, to match the requirement of my scene. You can see the script here. If you want to have a script, you can simply copy paste, like you can type it in your computer. Okay, let us continue with the scene. Yeah, here is my script for the scene, and it is in the IK module. This red color dotted line represents that IK module has been defined. And let me open the script, and this script has around 52 lines of code. And there's also initialization section here. This is the initialization section, and this is the main script. And you see, I have got the suction pad script. The script that I have shown to you previously, the suction pad script. I have made use of the suction pad script into the main script. The first line of code is activate suction pad is equal to function of active. If active, then it means that if suction pad gets activated, then simulation parameter active is set to be true, else the simulation parameter active is set to be false. Then these two lines of code you need not bother about. This is a threaded child script, and in the every threaded child script, you will see these two lines of code automatically. The Vrep, it automatically sets these two lines into your script. And let me define the initialization section. So initially there is a section pad that I have imported, and simget object handle. What this function does is, whatever objects you have, it saves it into a variable. This variable is predefined. You can put it like my object or something, anything, it's up to you, but make sure you use same variable all over your script, and don't get confused. Suction pad, okay. And the script for the suction pad, sim get script associate with object. It means the script associated with this suction pad is stored into suction pad script. Yeah, here I have used it here, suction pad script. And then the target of the robot, target dummy, I've saved it. And then the yeah, robot, this is also a dummy. And then the cuboid grasp, and these are like the uh, locations. Cuboid grasp or the dummy. Yeah, cuboid grasp is in these containers. Grasp, yeah. These are the dummy locations. No, yeah, here it is. I've added a few dummies. So this cuboid grasp, I'll teach you what it is. And I've defined the cuboid approach, and then the target position, initial position, and then the quaternion. The quaternion is a robotics concept. It defines the orientation, and then I have defined the maximum velocity. I have defined four parameters for that: zero point 0.4, zero point 0.4 meters per second, and then maximum acceleration also. A maximum jerk also is given, and then after that, activate suction pad is false. So in the main script, target P. Target P is the simulate object position of approach 1. So I'm storing the XYZ coordinates of this approach 1 into the variable called target P, and similarly the orientation is stored into the target O, and then I'm using the RML. RML means reflexive motion library. Sim RML move to position. So what I'm doing is I'm trying to make the target move with respect to the target base, and the position and orientation are nil with the particular maximum velocity that I have defined. And RML uses these vectors. This is the vector: zero point 0.4, zero point 0.4, 0.4. Four variables are stored into the single variable, that is the vector. And similarly, I am making use of maximum acceleration, jerk, target position, orientation, all those things. And the if you want to know how you can use this sim RML, yeah, we these APIs are very simple to use. Sim move to position, like the Vrep detects that you are using sim RMLs, and based on that it will show you the possible commands that you can use, so that you can avoid typing sim RML move to position. Just bracket open, yes, and it will show you the syntax, number result, and then table 3 new position, table 4 new quaternion. And this is the syntax for that, and I have followed the same syntax right over here. And yeah, and next comes the target P. Cube graph, I am saving it into the target P, and then target O is the object quaternion of the cube graph. And then say similarly I am using simRML move to position, and then activate suction pad is true. See, let me break this code into two parts. This becomes the first part, and this becomes the second part. So what happens in the first part is the robot it moves to the position, this cube grasp position, yes, and when it approaches, what happens is suction pad will be activated. It means that it starts sucking, vacuum will be created, so that the cube can hold the cube perfectly. So this is the first part, and the second part is the manipulator moves to the new target approach 1 position. Approach 1 is somewhere over here, so it moves there uh, following a particular quaternion orientation, RML, okay, and then it moves to approach 2. I'm saving it and I'm making the robot move to that position, approach to RML move, and then after moving it, I'm getting the drop position. I'm saving the position and orientation of this drop, and then I'm making the robot move to the drop position, and after it moves to the drop position, I'm telling the robot to deactivate the suction pad, false. This command deactivates the suction pad. Activate suction pad is false. And then same RML move to position to the now it moves to the original position, and then stop is equal to simulation stop. It stops the simulation automatically. Oh, there seems to be some error. Lua API call error, string robot based script does not exist in line 3. Okay, even with errors you can continue. This is the drop position, and as soon as it goes into the drop position, the suction pad comes to false. That's the point here. It should function like it's not functioning as expected. It's because of these errors. There seems to be some error with this. Uh, Probably a small error, maybe a spelling mistake or something. Actually, it should function. I don't know what happened at present. Okay. This is all about the suction pad grasping concept, and further we'll see this falling cube grasping. And let me open the script for you. Yes, and you will notice that the script is same for the script for this particular grasping and this scene. Both are almost the same. I'll just double click it. Yeah, box detected, and then sim set joint position, sim follow, sim target position, gripper close, sim wait. It will wait for some time, and then it returns back to the original position, sim follow path, and the initialization is also same. This is all self-explanatory, and I have already explained all these this script in the previous conveyor belt scene. Okay, this is the final scene, and this particular robot, it welds the component. This robot is a 7 degrees of freedom robot, and you see how good it is welding. And I'll show you a script for this, and this welding script is very simple. Yeah, and forgot to mention, all these are the graphs that I have defined it. Here you can see the angular velocity graphs are there, acceleration graphs are there, and tip position, tip orientation graphs are there. Yeah, here it is. I've defined all the graphs. Absolute position, acceleration, force. You can calculate the torque values, force values. You can do almost everything. You can plot almost everything here. And this is the welding torch, and I have got the welding torch from the actuators modifier. Yeah, from here. This is that welding torch, you know. Okay. Let me play that. This is a arc welding, and the welding is smooth with no errors or anything. And let me show you the script for that. And this only has a 6 lines of script, but okay. I've defined the path, and you see the path is lies on this component. This is that path, it's not highlighted. Let me highlight that for you. Yeah, here it is. you know all these points are the path points. You can define the path points from here. Yeah. uh, you see, I'm selecting different points here, and the respective points are getting highlighted in the path. 18, 19, 20. Okay, this particular path has around 38 control points. You can add, or you can edit the path by selecting the path and then clicking this orientation. You can change the XYZ coordinates, or you can even simply drag it accordingly. Like wherever you place it, the path, the point gets changed. You can even input the coordinates for this path, and if you want to add a new control point, just right click it and insert new control point after selection. Now 39th path has been added. Do you want to save the changes? Yes. And the target, welding point target, I'm saving it into the variable called target. And then the position of the path, sim get position on path, so I'm saving it into P, and then the orientation into O, and then sim move to position. The target has to move to position and orientation with the velocity of 0.01 and acceleration of 0.01. And then it should first it should move to the position, and then it should follow the path. After it moves, it follows the path. And while following the path, this velocity should be less, because welding doesn't occur if the velocity is more. It's all trial and error. 0.006 meters per second with velocity, and 0.001 meters per second square acceleration. And here you see that all you should get these ticks while performing the simulation. These ticks appear for dynamics enabled objects only. You see, this robot link 6, link 5, these are not dynamically enabled. Only these three are dynamically enabled. Wherever dynamically enabled things are there, you should get these tick marks. For more information about the dynamics, you can refer to my previous video, dynamics module. And the script for the welding robot is here, and this has 90 lines of code. And after importing the welding torch into the scene, I have made a small changes for this script of the welding torch. And yeah, I forgot to mention that you can click open scene and you will get many scenes are preloaded into your vrep, and two industrial robots, and you can make use of any of these scripts. Like you can refer it and you can get a new idea of these scripts how you can do. And yeah, and this is my probably my last video, and in case of any doubts or any clarifications, you can ask me directly in the comment section, or you can even email me. And thanks for watching. Thank you.